Good morning, Algebra. Today we're going to talk about scatter plots, and we're going to do a little flip lesson tonight. So tomorrow when you come, we'll do some real-life examples of this. Scatter plots just mean that when you have any kind of data that has two different variables, they call it bivariate data, you're going to end up with a graph. So you have two axes. You're going to end up with a graph, and when you do it, in math class, often your graph looks perfect like this, and it's a perfect line that goes through that whole thing. But when you do it in real life, what you notice is that the data doesn't turn out to be perfect. There's little tiny errors, either in your measurement or some other part of your experiment. And so oftentimes you'll get data that looks like this. You'll have a point and another point and a point and another. And your points roughly go, where you want them to go, but they're going to be off a little bit. Can you see that? Hopefully you can see those points. Maybe I'll make them bigger. So you have point, point. So if you look at that, roughly, that's proceeding upward. Okay, there's a positive trend in your data. I don't know what that might be. Maybe that's maybe this is the number of days in algebra, and this is the number of A's that you guys are getting on your tests. So when algebra started, there wasn't very many A's, and as we've gone along, you guys have gotten more and more A's on your test. Do you see that? But it doesn't go in a perfect line. Still, I can look at that and I can see an upward trend. There's a thing called a line of fit, and a line of fit is when you have a scatter plot like this. The reason why they call it a scatter plot, obviously, is because it's scattered kind of all over the place. When you do a line of fit, what you're trying to do is draw a line through the data in such a way that you're coming as close as you can to all the different points. So if I was just going to freehand this, I would draw it and I would go, roughly through there maybe. Okay? That's a pretty crooked line actually. But I'm not going to hit this low one and I'm not going to hit this high one. I'm going to go kind of between them. Not low, not high, between them. And I draw a line of fit. Okay? Then what I can do with that is, especially if I had this on nice graph paper, is I could turn that into a nice equation. And then I could do some predictions and work with the data a little bit more. So all I need to do is find out where is a point that my line of fit goes through. So it looks roughly like maybe I go through 1, 1, and let's see, 1, 2, 3, 4, 5, up 1, 2, 3. Let's say 5, 3. I know that's pretty rough. So I have these 2 points, 5, 3, and 1, 1. And you know how to make an equation from that. You just do 3 minus 1 is 2, the y minus y1, and the y minus y2. 5 minus 1 is 4. So we have a slope of 1/2. And yesterday, we learned about point slope form. So let's just take one of these points. Let's do the 1, 1. So y minus 1 equals 1/2, that's the slope, times x minus 1. And so I get y minus 1 equals 1/2 x minus 1/2. Take that 1, add it to the other side, and my final equation is going to be y equals 1/2 x plus 1/2. And now that I have that equation, I can use that and make other predictions about what this data is doing. Okay? For instance, I can predict things that are off my graph. After 100 days, so that would be my x thing, I would put in 100, how many A's would I predict? And then I work the equation, and I see 100 times a half is 50, 50. I would expect 50 and a half A's if the data kept going in the same trend that it's doing now. Okay? All right, so there it is. That's scatter plots, lines of fit. It's pretty useful stuff, and we'll do a little real-life research tomorrow. Okay.